Hello there. Okay, so this concept is about using four motors spinning in the same direction and use the control surfaces to cancel out the reaction torque of the four motors. This would enable me to use internal combustion motors spinning in the same direction. And it's easy enough to design the control surfaces in such a way that they produce the required counter torque. However, the gyroscopic precession in the system is not fixed by designing the control surfaces in a specific way. So it's easy enough to just hover around gently, and the flight controller can manage the gyroscopic precession. But as soon as you really start to tilt the craft and go forward, the gyroscopic precession kicks in and makes the craft go in a toilet bowl movement. So it veers off sharply to the left in the case of this craft. You could probably reprogram the flight controllers, but I'm not competent to do that at this point. And I'm trying to stick to the stock firmware because it's tested and tried by so many people, so it feels a lot more safe to use the original software, especially if I'm going to scale one of these up. Okay, so here's another concept. It's counter rotating propellers, and it's still in the single copter mode in the flight controller. I have tried to reduce the number of control surfaces, so here's only 3, and as you can see, they were driven by service via a sprocket or gear train, and you can see that it does not vector the thrust efficiently enough. They rather are working over time here to correct the craft. It's a slight headwind here, so that's why it's in such a weird forward tilting position most of the time. But I have to turn the gains up to very high values, which is alarm clock. That's something that's not really good in the design. It's not a stable design or rugged design. And it has the ringing action when you do a rapid movement. So it's like oscillating, like this. And it's a fairly slight breeze, so it really should be simple to fly around. And it does a lot of uncommanded movements in the air, so it's unfortunately not a good design for the flight controller I'm using. Yep. I crashed this several times, but this time was the the one that really did the job. It came back like a IKEA package. It was like totally flat. Really surprised how very smashed it was. Okay, so this is my latest love, and it's I'm just building on this old version to the left that worked really well. But I'm trying to move the center of gravity up by using a single motor, still counter-rotating, but I built a gearbox. So one motor driving 2 propellers in a counter-rotating fashion via a gearbox. And all this to get the center of gravity as high up as possible without making the aircraft ridiculously tall. So it's an old motor here. I don't think they are selling these anymore. Too bad. Howie King, they carried these before. Cheap and very good. I think they are 26-inch propellers at the moment. And the gearbox is made out of 2 angle grinders. So I bought the cheapest angle grinders I could find, and there are 750 watt angle grinders. So relevant power capacity for like this big drone. And I pulled out the bevel gears. First, of course, I was thinking about buying just bevel gears, so I checked out the hobby bevel gears for radio control cars. But as it turns out, the market for radio control bevel gears are not they are super expensive. So this set here cost as much as 2 cheap angle grinders, complete new angle grinders. So it was simply cheaper, and they are more appropriate size as well. So it was a good choice, I think. but since they are cheap, you can actually drill in the metal, which is a good thing when you're rebuilding it to a counter-rotating gearbox. You can both drill and weld these bevel gears nicely. Yeah, there's a support bearing down there in between all the servos. And this machine, yeah, you can see the aerodynamic dampening surfaces at the top as well. This machine flies really, really well. It's the most promising design so far. So there are 16 control surfaces, movable and 4 static, and it's divided into 4. The previous one was a tricopter thing with three axes. This is a 4 axis, so to speak, machine, or I don't know what do you call it, but it has 4 sets of rudders. So it's much more linear flying. It's like you can go to the left, right, back and forth, and it's very predictable, and it flies so well. It's severely underpowered at this point. It weighs 6 kilos, but it still picks up a lot of speed when you're flying it. And I would not think that the total thrust is more than 6.5 kilos or so. So it does not have much excess power. I'm going to do a punch out in just a moment in the next clip here. And you can fly it around close to the ground without having any oscillations or anything. Here I'm going to do a punch out. You can see how poor the power factor is. Here, that's max throttle right there. So with that little extra throttle or thrust, I can still make it move quite fast in the lateral plane. I'm going to accelerate forward here in just a moment. So, it's going to be a fast aircraft. And when I let the stick go, it doesn't oscillate or anything. The control surfaces really does seem to have a firm grip of the thrust vectoring. So I can fly sloppy, and it doesn't oscillate or surprise me in any way. And here it's flying in ground effect. So you can fly it a little bit higher in ground effect as well, but at this sort of setting it's just going like 4" 10 centimeters over the ground, and just playing around and feeling the gains, and it's rock solid. I'm just overwhelmed by how well this behaves. Super predictable, and it seems to be, the gains are set pretty low, so it's the previous designs I had to fiddle with the gain and go up really high, but this just worked with low gains, and I think it's a sign of the authority that the control surfaces has, which is very good, because you can suffer some failures on the servos and control surfaces and still have good control this way. So this is how it looks close up. 6 kilo of machine. The only thing I'm not showing here is the underside, and you would have seen that I have 2 separate BEC circuits there. So I have a 40 amp total servo power, because the servo, of course, they are not consuming much power at any given time, but the peak, here's the center of gravity. The peak demand when the servo moves can be quite high, so I have 2 of these small adapters coupled to the batteries, so to avoid brown out of either the servo's IC or the flight controller. Yeah, and one other thing that I was worried about was flying close to the ground. The legs are so short between the control surfaces and the landing feet, so I was also afraid that I would not have authority, thrust vectoring authority close to the ground, but it works very nice. So I can both land slowly and take off slowly without the aircraft starts doing weird things. Because if you're close to the ground, it might be difficult to redirect the air that's going down, but it's just not a problem, which I was quite surprised about. But that's a good thing. I can make the craft, a smaller form factor this way. Yeah, so now I'm just flying around for fun here and not doing any specific, test here. I'm thinking about upping the batteries are coupled in 2 pairs, so there are 8 cells basically to the speed controller. I could go up to like 10 cells. So the ECS can take 12 cells. But I'm opting for longer flight duration to be able to do more tests rather than impressive punch outs. But this punch out I did earlier, it was just ridiculously weak, and you can still reach pretty high top speed with it because it's so heavy. So that that vector that's pushing it forward when you're tilting it is still a significant amount of thrust, and it's fairly not too draggy. So this is a version that I'm looking forward to develop further. And right now, as I said, I'm working with two angle grinder bevel gears to make that happen, to the counter rotating thing. And in a larger scale version, I'm thinking about using outboard motor bevel gears, like in the 90 horsepower range if you were to scale it up. But that's just daydreaming as usual. But I'm just checking out what materials and techniques I could use to scale this up. It's a little bit weird sound when you're flying it. The gearbox makes a sort of unpleasant sound. It's only lubricated with grease, so it's not an oil bath like an ordinary outboard motor. So I expect it to be a lot more quiet if you had a real oil bath surrounding the gears. So just showing the response from the various stick inputs there. It's sort of mesmerizing to just watch the propellers go slowly in the opposite direction, perfectly synchronized. And the motor gets warm, but it's not hot, and the speed controller is not even warm. I think it's a 120 amp speed controller, and this consumes perhaps 30 amps or so. So I don't think the flight time is especially impressive in this version because it's so heavy. Due to the everything is oversized in it, but it's rugged and you can sort of crash it without breaking it, and that's very good when you're trying out a new design, of course. So I think there are optimizations that you could do to make it more efficient, but I'm mostly after the form factor and flight time as well, of course. Well, see you in the next one. Bye.